Okay, so thank you very much, everyone. Thank you so much for joining us. Let me just welcome us again. Thank you so much for joining us, Moses from Lagos, Nigeria. Thank you very much. We're glad to have you. Trust, thank you for joining us from Joburg, South Africa. Thank you. Oguchuku Boma from Lagos, Nigeria, Lagos State University, Lagos, Nigeria. Thank you for joining us. Inme Iyang from Port Harcourt, awesome. Thank you for being a part of this class. Let's keep the introduction coming, right? It's our pleasure to have you here. Alale Kanyinde from Goku Benue. We're super excited to have you with us today. You're all welcome. Saliu Sani, thank you very much for joining us. So the moment, let me just put on just a minute and we can get started in the next 60 seconds. All right. Okay, so my pleasure again to welcome us to this amazing masterclass where we will be looking at unlocking how to make it of natural language processing NLP and its applications in healthcare delivery, right? And we are already glad to have a speaker who will be walking every one of us through how to make use of NLP and ASR in healthcare delivery. Also, I'm aware that you are aware that we have an hackathon where you will have the opportunity to win up to $5,000 US. So I would request that as much as possible, you pay utmost attention, right, to this masterclass because it will be very extremely valuable for you. All right, so let's get started very quickly with the introduction and we can move into the main business of today. All right, so in the next few minutes, I'm just going to be introducing to us Data Scientists Network, DSN, and also known as Data Science Nigeria, right? And what we've been able to do over the last 2 years, for those of us that may not have the full view of what DSN is all about or what we focus in a nutshell, right? We are committed to raising 1 million AI talents and building mass market AI solutions that improves the quality of life and the well-being of over 2 billion people that are living in emerging markets. And over the years, we've been privileged to enhance and push this vision, right, with some of our accomplishment records and our works in artificial intelligence across Africa. And that's what I'm going to be telling you in a moment, 7 awesome things that you should know about DSN. So when you leave this call, you can hit your chest and say, okay, this is what DSN is all about. Number 1, right, we now have a global footprint with our presence in all 36 states of the Federation, including the Federal Capital Territory, and 7 other countries across 3 different continents. And that's something that we are super proud of with our headquarters here in Lagos and offices in London and Dubai. Of course, our campus communities are major footprints, right? And we have it spread all across the nation, right? So we just, you look through, you can go through our sites and read a whole lot more about some of the things that we've been able to do. Here you have engagements with stakeholders, with teachers, with young learners who are adopting artificial intelligence and using it in their own endeavor. Our efforts, right, has also not excluded our ladies, as we have been super intentional about building artificial intelligence competencies among our ladies with our DSN Ladies in AI program. So that's what you have there on your screen. Next, we also have our works across schools, right? The AI Plus Club for Schools, where we are helping young learners in K-12 schools adopt artificial intelligence and machine learning by breaking it down to the basics. We have developed a book that tells them and teaches them about artificial intelligence, Python programming, machine learning in simple to understand terms. And this is what we have done across schools here in Lagos and also all across the nation. Here you see what we've done in faraway Maduguri, where we're introducing students to artificial intelligence and Python programming. Okay, let's move on very quickly, right? Next thing that I need you to know very quickly, Teju, right, is an annual artificial intelligence summit where we hold a masterclass for executives and leaders of businesses, right, and teaching them how to begin to implement and integrate artificial intelligence into the work that they do to improve their outcomes and the results that the businesses get. And so this is one of the things that we are very much intentional in adoption of artificial intelligence. Number two, right, we are proud to let you know that 2 products that we are developed, conceptualized, and initiated here in Nigeria by DSN were selected in the 2021 Global Top 100 AI Products by the UNESCO IRCAI. One of those products is our adaptive learning engine, where we are using basic feature phones and SMS to support real-time learning, with over 8 million learners who are able to access learning. This product and the entire project was funded and supported by the Mastercard Foundation. Also, we had the Prescribe Right, which is an AI-powered optical character recognition system that aims to reduce medication errors across low-resource areas and ensure that there is accuracy in these prescriptions and the delivery. So these 2 products were accepted and recognized among the global top 100 AI products. All right, that's number 2 thing that I needed to know about DSN. Let's move on very quickly to the next thing. Hi, Teju. Okay. Hello, Teju. All right, so number 3 thing that I needed to know very quickly, right, about DSN has been our focus. Here you see where we are, the global top 100 products, right, the badge that was given to us by the UNESCO IRCAI. Also, our work has been mentioned over 10,000 times in various academic papers as curated on www.academia.edu. For those of us that may not know, academia.edu is the world leading aggregator of research and research publications by different personnel, from students to professors to doctorates and postgraduates in degrees, right? This is something that we are super proud of, as at over 10,000 times we've been referenced as a leading source and a leading support and partner delivering artificial intelligence learning and solutions across the world, right? So you can check that out on www.academia.edu and read more about it on our website. Also, the Massachusetts Institute of Technology, MIT, one of the world's foremost technology organization, university, has recognized our work in generating open data, the kind of data that can be used to improve African fashion by training computer vision algorithms in order to ensure that the world can see what we're doing and the amazing work we're doing in an African fashion industry, right? We've been able to generate that open data, and Massachusetts Institute of Technology was recognized what we've done. 5 of our academic papers were recognized and accepted at the world foremost AI conference and also at NeurIPS, right? So here you see some of those papers. I would request that you please, why not? You can go ahead on our website and read a whole lot more. I wouldn't be able to dive into this, but it would be my pleasure, right? And I believe it would be very awesome and valuable to you to go ahead and to our website, get to learn a whole lot more about this and see how they can be valuable and beneficial to you. Here you have some of our leading papers. You can check them on Google Scholar, ResearchGate, and GitHub. Let's move on very quickly to the next main item that I need you to know. All right, moving on quickly, here you have our German Institute of Labor also recognizing some of the work that we've done. Labor Economics also recognizing the work that we've done, right, as the #2 AI center in Africa, ahead of many universities, right? This, again, is something that we're super proud to let you know about, right, in order to let you know what we've been doing in driving the vision of raising 1 million AI talent and building solutions to improve the lives of 2 billion people is being recognized globally. And that's something we're super proud of. So here you have some of the top leading artificial intelligence and AI platforms and conferences also recognizing the work that we do, such as ICLR, ICML, AAAI, and Deep Learning in DABA. Okay, here we have work being recognized again as the #1 artificial intelligence learning community and solutions delivery network in Africa, where we were able to win the Matai Impact Award at Deep Learning in Daba. Okay, this is some of the things that you can read a whole lot more on our website. Let's move on very quickly, Teju. Okay, the next thing we are, some of our papers also accepted and winning the best academic poster at the 21st edition of the Global Economic and Compensation Conference in 2020. So it's something, again, that we are proud of and something that we, of course, would like you to be a part of. We are the only African finalists at the 2021 X Prize competition on building artificial AI algorithm to address COVID-19. Again, right, this was something that we worked on in 2019 on how to improve solutions to combat the spread. Okay. Our work has also been presented here. You can see on the screen our founder and lead mentor, Dr. Olubayo Adekombi, presenting academic papers at some of the formal scientific and practitioner AI conferences in the world. All right, let's move on quickly for sake of our time. Number 4, we are proud and excited to let you know that our consulting, training, and solution delivery has allowed us to work with some of the world's leading global development agencies and multinationals, right? Here you can see on the screen, among all them, we have Meta, TikTok, MasterCard Foundation, Flowminder, Bill and Melinda Gates Foundation, and even banks and financial institutions in Nigeria, Access Bank, Heritage Bank, among others. We've also been strategic partners to the world's leading academic and social good AI groups and platforms such as Artificial Intelligence for Development Africa, ZND platform, Vodan African Asia, Black in AI, Datacon, and Machine Intelligence Institute of Africa, among others. So you can see here again some of the companies that we've been able and privileged to work with in the course of our 6+ years of existence. All right, let's move on very quickly to the next thing. So we are also beneficiaries of the Swedish and the Canadian government-funded joint research work with 2 leading West African universities, where the University of Lagos, Nigeria was the lead university on the application of artificial intelligence in education with a grant of $1.2 million. And you can read more about that on eduaihub.org and see what we're able to do with these universities and with the winners of those grants. Okay, our footprints in building these solutions. Remember that our commitment is to drive the development of 1 million AI talents, raise them, and also to build solutions, mass market solutions that improve the quality of life of about 2 billion people. And we are proud to be able to let you know that we've done some huge heavy lifting in that area with our products, macro tutor in education, spot on for local addressing, geospatial, and e-wallets for small businesses across Nigeria. And Prescribe Right that I mentioned earlier, helping to improve errors in prescription, improve accuracy of prescription by detecting errors through the OCR system. Okay, let's move on very quickly to the next one. And I will be introducing our guest in a moment. Very quickly, the next one, we have been able to also work with organizations and agencies across the states and the federal level in Nigeria to drive artificial intelligence for social good. And that's what we have in our very next screen. Move on very quickly to the next screen, Teju, where we used a call data records for social good, right? Working with government agencies and the private sector, right, on how to leverage call data records, CDR, to improve disease tracking across low resource areas and regions in Nigeria, right? This is something that we're proud of here. You can see our representatives with representatives of the government, right, working on this project. Also, we've taken, move on to the next screen, we've taken our expertise and our core knowledge and partnered with the organization Enhancing Financial Inclusion and Access, EFINA, right, in building the National Financial Inclusion Dashboard for Nigeria. this we did in partnership with the central bank, where we were able to access data and we're able to build this. And so what you have on the screen is the dashboard at a glance. You can check it out on the website that was shared by my colleagues right there and see much more what we were able to do, and even play around with the data, with the visualization, and see what the value that it was able to present for our clients and for the government. Okay, yeah, this is one of the products that we built also to help companies understand how data fluent they are. And once they are able to identify their data fluency and their data adoption across the entire organization, then they can plan a data development and artificial intelligence implementation roadmap. The platform is called Data Fluency. You can check it out at datafluency.datasciencenigeria.ai, right, and see how companies can use it to measure how fluent and how adaptive they are when it comes to the delivery and the usage of data. Yeah, is our community at a glance. It is something that we are super big on and super excited about. Our global community of over 500,000 learners who are building their artificial intelligence skills and also getting global delivery networks, joining organizations, going on scholarships, joining fellowships from our community. Of course, my colleagues are going to drop the community link. For those of us that are not a part of our community, I believe that a lot of us on this call are already a part of our community. But if you're not yet, why not? It will be our pleasure to welcome you to become a part of our community. Okay, now let's move on. I believe that I have our speaker and he's ready on the call, but I'm just going to walk you through a quick introduction of our speaker, who will take over from me right now once I'm done with the introduction. Like you are aware of, our speaker for today is Dr. Toby Olatunji, who is a physician turned machine learning data scientist, right, focused on clinical natural language processing and automatic speech recognition, ASR. Dr. Toby founded Intron, Africa's first speech recognition medical records, accelerating the transition to digitized care for clinicians of all types and speeds. Intron provides technology infrastructure and financing that eliminates technology adoption barriers across Africa. Now, over the past decades, he has worked as a clinical NLP scientist at Health AI, Amazon Web Services, AWS, Elitic Incorporated, a radiologic AI startup in San Francisco, Cambian Health Solutions, and also consulted for other various startups and healthcare institutions in the United States and also across Africa. His research has covered across accented speech recognition, algorithm, bias, neural and ontological augmented information, retrieval, negation and uncertainty detection in radiology reports, with your genomic multimodal models combining imaging, pathology and radiology genomics as RNA and DNA, unstructured text and carrier biomarkers to create learnable patient representations. He has published at NeurIPS, MIDL, EM, NLP, and other machine learning conferences and workshops across the world. He holds a Bachelor of Medicine, a Bachelor of Surgery, MBS, BS degree from the College of Medicine in Ibadan, University of Ibadan, a Master of Science in Medical Informatics from the University of San Francisco, and a certificate in health management from Yale School of Management, and also an MNC in computer science at the Georgia Institute of Technology. Now, today, Dr. Toby will be walking us through how to unlock the power of NLP and ASR to build solutions in the healthcare space. And I'm glad that we have him here. And I hope that you're ready to learn with Dr. Bayo. I'm Dr. Toby again. I keep mentioning my founder. Apologies for that. Okay, Dr. Toby, I will just ask if you're on the call, you can just go ahead to respond. Hi, Dr. Toby.
Hi.
Yeah,
nice
a pleasure to have you here today.
Thank you. Thanks for having me.
All right. So I believe you can go ahead right now, and I'll return when you're done. Thank you, Dr. Toby.
Cool. I'm assuming I can share my screen, yeah?
Yes, you can go ahead to do that.
Okay, cool. Let's see. Let's see. Okay. Can people see my screen? Let's see, where are we?
That's so people can see your screen. Yeah.
All right, I'm just trying to rearrange my screen. Okay, great. Hi everyone. It's great to be here. That was a fantastic presentation. I'm really amazed at all the things that DSN has achieved. I think the organization has done way more than I even assumed, and that's really great. The team.
Can you hear me?
Yes, I can hear you.
Just quickly, yeah, it would be great to have your slides on a slideshow. So you could just, to make it larger so everyone can see it very well. So use the slideshow icon. Yeah, awesome.
Okay,
yeah.
I had it started. That's what, yeah. So, okay, this is better.
Right. Thank you very much.
Okay, cool. Okay, can everyone still hear me okay?
Yes, we can.
Okay, cool. Just figuring out what's going on. Yeah, just I typically want to be a little bit interactive when I do talks like this, and so I just how many people on the call have done anything with natural language processing? Can you just type in the chats, and I want to have a rough idea how many people have worked on natural language processing in the past. Just feel free to use the chat. I'll try to monitor. Okay, let's see, 3 people. Any others? Okay, so NLP, okay, that's 5, 6. Yeah, because I want to know the level of exposure people have so that I can modulate, like I don't talk above their heads or make it too simple if they're already experts. Okay, see a couple of people, so that's good. So it means that that's about 10% of those on the call or thereabouts. Okay, so that's fair. Okay, cool. So let's get started. We have a bit of time here, so I'll rush through this. This never can. Okay, so I think we'll just rush through a few things in the time we have. I'll cover some fundamentals. I'll talk about NLP use cases in healthcare. Then I will touch on some basics of NLP, how to use it, how it works, and then hopefully we have some time at the end to touch some practice problems. And I will be looking for people to respond, ask questions as we go. Okay, cool. No, we're doing a very basic overview here. We're not doing doing any expert level things at this call. This is just supposed to be like a simple intro to NLP in healthcare. All right, so just like to get us started, what is natural language processing? And I pulled this definition from IBM. Basically, computers understand numbers, and they are built to run computations, calculations. That's what they excel at, and they're not very good at text. So natural language processing is the way that we try to help computers understand written text or spoken text or spoken words. So if I say good morning, if I type good morning, the computer does not understand what good is, what morning is. It just sees strings. And so natural language processing creates multiple ways we can help the computer understand what we're trying to say. Or if you say, tell me the is it going to rain in Lagos tomorrow? The computer does not understand that sentence. Natural language processing helps it to figure out what you're saying so it can give you the appropriate response. And of course, what is healthcare? Everyone thinks they know what healthcare is, but healthcare is a pretty broad space. And healthcare is not just going to the hospital or taking medications. It's the entire process of creating products for healthcare, caring for patients, and getting paid for that care. So a huge part of the NLP applications in healthcare, for example, are things like insurance, things like billing, helping hospitals get paid by companies, by patients, and the medical device development process and the drug development process, clinical trials, and things like that. So there's many ways that natural language processing can be used in healthcare. So we'll jump straight to NLP use cases in healthcare. If anyone has questions as I talk, just please feel free to put them in the chat. I'll be able to pause from time to time to take some questions. All right, so I think one of the really interesting use cases for natural language processing in healthcare is summarization. And like you can see on the screen, sometimes you are requesting a study like an MRI or a CT scan for a radiologist, or maybe let's even say it's a pregnancy scan and an ultrasound scan, and you want to provide some context to the person who is going to do the scan. Today, the doctor has to personally look through the record and write out a summary of, oh, this is a 35-year-old woman, this is her first pregnancy, she went to school here and there, she's had these conditions in the past, and actually write all this. So take their time to write out the patient's history before and include it with the order that's going out to the radiologist. So one of the ways that NLP can be used in healthcare is to help doctors create that summary, and then they can just review it and see if they need to add or subtract anything, and then send it out. So this sort of service can save a lot of time when doctors have to write out summaries. One other really interesting use case is, let's say you're a doctor, you haven't seen a patient in the last 2 years or something, and you're forgetting about them mostly, and they're coming back, but they have a long history. Maybe this is a hypertensive patient or a diabetic patient that's maybe 50, 60 years old, and they have a huge history. You want a way to be able to summarize that history. Let's say they're coming to clinic tomorrow, and you just want to read up on what's going on in their past history, and then you want a way to synthesize all that and just give me a summary, 1 paragraph, 2 paragraphs I can read over. So that's one potential use case for natural language processing in healthcare. This is so entity recognition is is a very fancy way for saying what is in the document. So for example, given a tweet or a sentence or a paragraph, can you tell me which medical conditions are mentioned, which drugs, for example, are mentioned in the document? So entity recognition models help you scan, like you can see in this image, they help you scan the text and identify these are the medical conditions, these are the drugs, these are the body parts that I mentioned, and then you can use this for research and then even link it to other external knowledge sources. So for example, if the document mentioned paracetamol, for example, the entity recognition would find the word paracetamol, and then there's something called entity linking, which then checks your medical dictionary or your pharmaceutical formulary and checks paracetamol and says, okay, what is the correct dose of paracetamol? What is the what dose should be given to patients at this age? So let's assume you are a doctor, you are writing a prescription and you write paracetamol. This system is able to go out and look for the correct doses for paracetamol in different age groups and helps you avoid medication error. So for example, if you are going to by mistake type 1,500 milligrams, it can already say, because I know you're talking about paracetamol, and I'm able to link to an external dictionary formulary to tell me what the correct thing is. I can already flag that, hey, the prescription you've created, the dosage is higher than what it should be. Basically, I can also do the same thing for lab value for diagnosis. So this is one of the most important parts of natural language processing in healthcare, and it's used for clinical decision support. That's one way that NLP can increase safety and the quality of patient care. Let me know if people have questions. So of course, I've already touched on this a bit. Many hospitals now use HMOs in Nigeria and many countries across Africa. They have to fill their claims form at the end of each month. For example, they have a list of patients they saw. These patients are HMO patients, and for most HMO patients, they pay the hospital after the hospital has cared for the patient. The patient goes to the hospital, gets care, whether it's outpatients in clinic or inpatients in the ward if they're on admission. And then after their care, the hospital has to write out the bills and send to the HMO to get paid. Today, many hospitals, in fact, almost every hospital, they have to manually repeat all the things that they've done and write it in a claim form and send it to the HMO. And this is a very huge pain point, both for the HMOs and for the hospital. So a suite of NLP models can go in and just extract what the HMO, what the claim needs, and fill up and automate and auto-populate the claims form, basically. And once this is done, the person at hospital can just go and cross-check it and then send it out or correct anything that needs to be corrected. So it means a task that will have taken 1 hour, 2 hours is then reduced to like 5-10 minutes, and this can speed up the work that the hospital, I mean, reduce the stress that the person has to go through every single day. Another really interesting one that really became very popular during the COVID pandemic was chatbots and question and answering. Because COVID was very new, people had many questions and people didn't know anything about that. So they would ask questions everywhere, anywhere online. And it became obvious that there were many fake sources of information. Just anybody saying anything, I will just respond and say, hey, COVID is this, COVID is that. So I think many of the healthcare organizations like CDC, WHO have to then find a way to present official responses, official information, credible scientific responses to people in the form of either websites, chatbots that people can go to and ask questions and respond. This is useful not just for patients who want to get themselves educated. It's also relevant for even doctors who want to find out more about some medical conditions. One really interesting thing that I've seen some companies do here in the US is for history taking. So a patient comes to clinic, they are being seen, and instead of spending all the time waiting for 3 hours for the doctor, the patient gets a text message, they can respond, ask them some questions about their health. When did your sickness starts, when how many days ago, how painful it is it. Obviously, you can do this as just a simple questionnaire, a Google form, but where you start to bring in natural language processing and AI is where you have to ask follow-up questions. So based on, okay, the person says, I have a headache. Then there are follow-up questions you have to ask, like what type of headache, when did it start? And then based on their responses, you have to figure out the next best question to ask, which is going to be very difficult if you're going to use like a basic like Google form or survey form. You need some intelligence to understand what they're saying and to give the appropriate response and ask the right next question, basically. How are we doing on time? Okay, so the other very obvious one is search, which is the your Google search and now ChatGPT, where you need some information, and for example, if you work in a hospital and you're looking for a document in the hospital, maybe the procedure for maybe applying for a leave at your hospital, you can't go to Google to search for that because that information is not on Google. So, but if you have your own small Google within the hospital, or you're looking for research papers and you have a website like PubMed or something, NLP is what helps you search for those the right contents, basically the right documents, the right articles that you need. So there's multiple ways that people have done searching in healthcare, and I think this is going to continue to be a huge area of research. Another very interesting use case is patient selection. So for example, you have a new drug that you're developing, you're in a clinical trial, and you want to find, and of course you have some inclusion and exclusion criteria. You want to find the right patients that fit your criteria for the trial. Of course, you can ask people to go and search all the patients. Maybe you're a big hospital, there are like 100,000 patients, and then you ask people to go and search manually, or you can build an NLP system to go and look for the patients that meet your criteria. This becomes very interesting when you start talking about patient similarity. So let's say we manually found 5 patients or 10 patients. Maybe someone sat down for 2 weeks and was able to find 10 patients. Now that you have those 10 patients, you can then use a patient similarity algorithm to find similar patients to that patient. So using that, at least those will be your index patients. Then your NLP system can go through your medical records and find patients that are similar to those patients, and then you start to build your cohort. You can then reach out to them to ask them if they're interested in the trial. Some of them you might not be able to even get across to them. Interesting. So some of them you'll reach out to them. You would be able to find their numbers. They'll respond. Maybe only 5% of the people you reached out to are respond. So you have to go back again and repeat that search and get the response. Let me address some of the questions that I'm seeing in the chat. So for people looking for PhD topics, feel free to reach out to me on LinkedIn, and you can share whatever ideas you have for if it's an NLP application in healthcare. I agree, we can discuss that. I think someone said ChatGPT is not for search. That's an interesting way to think about it. I think ChatGPT is primarily a question answering system. And if you think about what Microsoft is doing right now, Microsoft actually has integrated ChatGPT in Bing search. So they're actually making it an alternative for search, because you can ask it for something and it gives you the answer. And usually you are searching for something. So that's at least one major use case. That's one of the major reasons why Microsoft even acquired ChatGPT. Someone's asking, how can you use NLP in drug supply chains? in terms of essential drug availability in primary care centers. I'm not sure. I think if you have, I think I have a slide that talks about drugs. I'm not sure, but for in terms of like how you supply drugs to people, I think NLP will be more useful if you are trying to find the right patients where you have documents, where you have text, then you're trying to leverage that text for some use case. That's where NLP is useful. So let's say you want to check how often a drug is being prescribed using the notes from the clinicians. You want to check how often this drug is being prescribed, just to understand, should you begin to order more? Should you begin to predict demand? Yes, then natural language processing can help you process your text documents and figure out what dosages were given for different medications. Patient similarity algorithm. I think so basically how it works is that if you know this patient, this patient is the perfect description of what I want. That patient has some features or attributes, maybe their age, their gender, the comorbidities, that's like the diseases they have. Maybe they have hypertension, they've had it for 10 years, they've had a stroke before. So the patient has some characteristics. And so you use you create like a vector or a representation of the patient using those characteristics, and then you using some form of embedding for your patients or that representation, you look at all your other patients through their own representations, and then you can find which patients are most similar to your index patients. And this is the same way you will find, for example, synonyms in text using some form of similarity metric like cosine similarity or something. Any other question? What's my name on LinkedIn? It's Toby Latunji. Thanks for answering. How does one develop the competencies I have? You have to study. There's no alternative to that. You have to go to school and study. I mean, not necessarily go to school, but there's a ton of studying and practicing to do, and you have to give yourself time. You have to give yourself a few years. Language translation, I have a slide on that. Automated attribute coding, yes. This is something. So if you work in clinical research, so there's something called coding in research in clinical research. So for example, they try to categorize. So I mean, a simple one is to say race. So for Nigeria, for example, maybe you have a cohort of 1,000 patients, and you used maybe their race, their tribe, for example, to be maybe Hausa, Yoruba, like out of Fulani, and you then do what's called coding. You can then change those tribes to numbers. So let's say number 1 is Hausa, number 2 is Fulani, number 3 is Igbo, number 4 is Yoruba, and all that. And so they do something called coding to try and simplify the information so that it's easier for their software systems or their SPSSs and things like that to process that information. So that's something that if you had text instead, you can easily predict those categories. So you can automate. Because what happens is that a human being has to go through the document or the interview or whatever to write out, oh, this patient is 15 years old, they are from this state, they're from that state, they have this disease. So they have to manually do that information extraction, either from some interview they've done or from some survey. If you had an NLP algorithm, you are able to just read that text and predict those codes, so to speak. So coding in this case refers to like clinical research, not programming. I mean, it's a form of programming anyway, but let's see if I can take a few more questions. Drug supply chain. Okay. Where should I look for internship? I think we can take career related questions at the end. Okay, great. So what's the
Doctor,
yep.
Yeah, so just so you're not derailed, right? We already have a Q&A session at the very end of this meeting, right? Where you have the time to address all of the questions. So I would ask, wouldn't that be fine, right? So you're not derailed in your line of thoughts for your slides.
Right. That's fine.
Yeah, my colleagues are already picking up all the questions, and then we'll roll it out in the Q&A session at the end.
Great. That's fine.
All right. Thank you very much.
That's fine. Cool. But I definitely want to encourage people to continue to ask questions, and there are some that I may stop and answer, and then the rest I will leave till the end. All right. Awesome. Let's move forward. I think one really important application for NLP is event prediction or outcome prediction, and this is this is a project I've worked on in the past. That's what I work on every day. Because the most important thing that people want to know is how likely is it that my son, my daughter, my uncle, my auntie, how likely, will they get well? What's the chances that they will recover? They're going into surgery for this really expensive procedure. What are the chances of a positive outcome? What is the risk? And in the screening setting for TB, leprosy, whatever people are screening for these days, breast cancer, colon cancer, prostate cancer, you want to say, given this result, given this report, can you give me the risk of them progressing from stage 1 to stage 2 and all that? And so natural language processing algorithms can help you do this to a degree. For example, you have 5 eyes. So a project with that was trying to predict 5 classes of mental health disease. I don't know if it was Alzheimer's or something. And given the patient's medical record or the patient's history, you want to basically determine the ones that are more at risk for a late stage disease versus early stage disease. And for those who are at risk for late stage disease, you want to identify that cohort now and start to administer interventions that can slow down their progression to an end stage disease. Like I already mentioned about drugs, you can also predict is this person likely to have a drug side effect for a drug? Are they likely to have a drug interaction based on the current drugs they are taking? So just many really interesting ways to use natural language processing to predict outcomes. I think I'm almost at the end of this section at this point. Let's see, let me skip something. Okay, then this is something that's many doctors don't like to hear. I've worked on a system previously that's tried to help check documentation quality. And we're currently talking to many hospitals about how to help them also do this. But basically, you look at the documentation that one doctor has made, and you compare it within the same department to documentation done by all the other doctors, and you want to check, okay, how far is this person from everybody else? So let's say it's a department that has 20 or 30 doctors. Normally, you have to have a person manually go through the documents and read each person's document, which would probably take them a couple of hours. But this is something that an NLP algorithm can do in seconds, minutes, if not seconds. And then it goes through everything and presents this. These are the people that are very different from everybody else. Kindly take a look at it and see if there are any issues here, or if there's any need to talk to this doctor about improving the quality of their documentation. One other use cases, if a doctor prescribes a medication and there's no evidence, there's no reason. So let's say they say, oh, take this drug, and you look at the notes they wrote, the history, there's no reason why they should be getting that drug. And I've seen this a number of times. Maybe it's a mistake, or maybe it's the patient just requested it. You have the opportunity to flag that, and whoever is doing your quality assurance looks at it and says, hey, doctor, why did you prescribe this medication based on this person's history? This patient is just 20 years old. They have these symptoms. Why are you prescribing tramadol or paracetamol for this person? And then they can explain or realize that, okay, it was a mistake, and then they can correct it. Of course, speech recognition, which is what we do at Intron Health. Besides just like transcribing speech to text, there are like multiple applications of voice recognition or speech recognition in healthcare. One of the very interesting ones is like diagnosing what illness a patient has just based on their voice. I saw a really interesting project recently where someone created a device that could, based on how someone coughs, the device records the sound of your cough, and just from the sound of your cough, they can, I think, predict your risk of, predict what disease you have. I think they currently do about 16 different diagnoses. They can say, based on this cough sound, this person has COVID or something like that, or a flu or something else, or a viral infection. There are just a lot of other interesting applications of voice in healthcare. And then lastly, I talk about translation. I think we talked to a hospital in the north, in northern Nigeria. I think they were in Kano or Kaduna. And I think the doctors are Yoruba or Igbo, and they're saying, okay, when a patient comes in, they're speaking Hausa, is there a way that our system can help translate directly for them, so that, because having to wait for a relative or someone that understands English and Hausa, how many translators can the hospital employ? How many patients have a relative that speak English? So because today you have to wait, the person has to talk, then they have to translate, then they tell you, you then respond to the person. It just doubles the time for the visit and just makes life very difficult for everyone. So if there was a system that could help bridge this gap, that's something that will be really helpful for healthcare. So just multiple projects that are possible in natural language processing. Okay, so we're at about 30 minutes. I think we can switch gears to talking about like how to start to practice NLP. So this is I don't know. I can probably pause here to do a few questions before going into the technical side of things. Do people have are there any of the questions that I can take right now before we get to, because I think once we get to the technical side of the conversation, questions will be a little different. So let's see, is there any of these questions you think I can take right now?
Okay, so I think you've taken a lot of them already, right? There are no new questions on the comment session. Okay, Tikaloma asks, is there any platform or architecture like ChatGPT that can be tweaked for research work and documentation, document summarization? Yeah.
Yeah, there are actually plenty. Not like for ChatGPT specifically. There, I think Microsoft just released what they call BioGPT, and you can, yes. So you can. So that is actually a model that you can download. You can use on your own laptop. Well, maybe not your laptop. Maybe Google Colab, or if you have access to some compute. So there are definitely many alternatives. There's T5. If you Google summarization models, there are a bunch of summarization models that you can fine tune, you can tweak for. Yes, so there's definitely a large body of work on summarization, even in the healthcare space before ChatGPT. But at least there are 3 large models if you want to, if you're looking for large models in the healthcare space. There's BioGPT, there's PubMed GPT, and I think Google hasn't released theirs, but I think there's a hospital. So I think NVIDIA released one with a hospital in Florida. It's called I think it's Bio. I think I wrote about it. It's not Bio Megatron. No, that's not the name. There's, I mean, if you Google it, I actually wrote an article about it a couple of weeks ago. So at least there are those three large language models that you may be able to fine tune, and they all will have like smaller versions that are more that you can tweak. And then besides the large version, there are the regular smaller models. Like I think there's Pegasus, and there are few others that do like summarization. There's BART. Yeah. All right.
Thank you very much, Doctor. Quick one. Yonda asks, can NLP be used in optimizing healthcare supply chain? Can NLP be used in optimizing healthcare supply chain?
Yeah, I think I addressed that in part before, and I said if you didn't have a system at the health center or at the community level to track prescriptions, like if you have a good inventory system, one thing that you could do is to say we have you look at the text from the medical record or prescriptions and process it using natural language processing to do counts of medications, doses, and you can use that to get a summary of what the trends are like for you. So you have to layer some analytics and business intelligence on that, and then you may want to build another model to even say, okay, based on the data we have now, can we predict in the next 3 weeks, in the next 6 weeks, in the next 7 months, how many units of this drug we would have. So if you have a good inventory system, you probably don't need NLP for that. You can just simply use any predictive model to do that. I mean, I did a project some time back predicting how likely a patient is going to come back for an appointment in 3 months, in 6 months, and all that. And so it's possible to use predictive models to do that without natural language processing.
All right. Thank you, Doctor. I hope your question is answered. So, Doctor, let's take one more before you go into the practical session. Check, that's his name. He said, what's the difference between cohort selection for research and patient similarity?
Yeah, so they are mostly part of the same use case. So again, cohort selection is the goal. You are looking for a group of patients that match a particular criteria. Patient similarity is one of the ways you can get there. So the normal thing will have been to go and check all the records manually and be looking at, okay, does this patient meet, does this patient not meet, which will take you hours. And I said, let's say you're looking for 100, 200 patients. Let's say you manually find 10. Then you can say, based on those 10, can the algorithm go through the patient record and help you find, for each patient, get me 10 patients that are similar to that patient. So you have a patient similarity algorithm that can do that for you. And so you go from 10 patients and you can get 100 patients easily by just using that. I mean, there are many other ways to do cohort selection, but at least that's one way that people have used natural language processing in the past.
Right. Thank you, Doctor, for that. So we can go into the practical session now. But they've asked that if we have materials that we can share with them much later, right? Of course, this slide we would love to share with them because they've asked for it, right? So they can always go through it later. But we can go into the practical session now because of our time. Thank you, Doctor.
Yeah, okay. So I think what I can do, I need to share these links with people somehow. There's two links on this page. Let me see if I can copy and paste them somewhere without causing too much trouble. Let me put them in the chat so people can at least use that to follow along some of the things I will be saying when we get there. But at least you have this and you can use them as starter material for your own projects. So they're just basic things, basic pages that can help you. All right, so I've shared those two. At least this will be the two notebooks I'll be using for most of this. And just to save time, I won't run the notebooks themselves. I'll just let you guys do that at your own time, but I'll walk you through the general approach to understand how, at least if you're to do a very basic NLP project, how would you go about it? So if we have enough time, I'll go to these two problems, but I would like to start with the first problem. It's a very simple problem, and I think we should just go about this in a more practical way. So I would like to ask the group, if you had an NLP problem where you have a bunch of sentences and you want to separate the ones that are medical from the ones that are not medical, can people use the chat to say what some rules? Let's assume that this is a rule-based system, very basic rule-based natural language processing system. You have some sentences that are medical related. I have sentences that are not medical related, like sports, entertainment, news, legal, just different domains, and you want to separate the sentences that are medical from non-medical. Can people share what are some of the rules you might want to write? I'd like to see people's suggestions in the chat, so I just make this a little bit more participatory. Do people understand the question?
But I think you want to take it again. Okay, they understand the question, because I was wondering why the answers are.
So if you okay, maybe a simpler way to explain it. You have a list of sentences. Maybe they are tweets. Let's say they're tweets on you have a list of tweets, and you want to. So you are not using a classification model. You want to write out some rules. Okay, what kind of rules would you write that will help you say if this sentence matches this rule, is more likely to be a medical sentence. If it's not, it's a non-medical sentence, for example. I see some really good ideas are coming. Okay, someone says medical terms. You have a list of medical terms. That's definitely a very good approach. You may want to think about something like if the sentence contains the name of some celebrity or some maybe football player like Ronaldo or Messi or something like that, it is less likely to be something that has to do with medicine. If it contains like things like awards, Grammys, things like that, or Beyonce, it is less likely to be a medical text. Yes, I think I saw if it contains the word disease, or I saw someone said about a wound or pain. So those are just very practical ways you can and start to think about creating just a very basic rule-based system. I see some people here are very advanced. They're already talking about classification model, topic modeling. Those are all good, and they are a little more advanced. But we're just saying at the very basic level, if you are going to use a rule-based system, you can use a a yes, you can define a list yourself, or you can use one way to do it is to do a medical dictionary or directory or something that has a list of medical terms, and you can just query against that and say, hey, does this sentence have any of these medical terms at least? And that already gives you okay. So I think those who are responding have at least some idea how to. I think someone said body parts. So pain, body parts, if it mentions like knee, stomach, head, like head or headache or things like that, you'll be able to. All right, so that's a very good baseline you have. So I mean, if we're able to come up with likely rules, then it looks like we already have a good baseline to start to think about natural language processing, because that is what essentially you are trying to automate this process. Instead of coming up with the rules yourself, you then want to go beyond just doing the rules. I mean, coming up with rules is also natural language processing, because the computer will not be able to answer the question if you didn't provide it some of those rules or those lists. Okay, so that is the first step. So that's basic. Then you want to go to other advanced methods, and we'll touch on a few of them in the next couple of minutes. Someone's asking, what is an API? An API is, in a very simple sense, it is a format of asking a question to a computer. So usually that computer might be a server on the web somewhere else, and they give you this format that if you want to ask me this for this kind of information, this is the way that you specify your question. So don't ask me what is a headache. You must say your name, you must say your ID, and then you put your question. So that's an API request, and you can send that request to a server. All right, let's go to looking at an actual implementation of how you start to think about NLP basics. I think some of the first things, based on what we've discussed about problem one, I would come back to these questions towards the end. So if you are going to try to automate this process of classifying a tweet or documents or sentences basically into medical versus non-medical, just to do the basic blocks of NLP, one of the approaches that you guys have already talked about is called bag of words. So you can look at the sentence, and just based on the words that exist, which is what you guys have already said. Maybe there's pain, there's wound, there's headache, or there's a list of diseases somewhere, or a list of celebrities. So that's just looking at what words are available in the sentence, and you can use that to already start to classify. And so that's the word level. The other one you can use is what's called engrams, and engrams is like sequence of words. So instead of saying just a single word, so let's say you have, for example, your knee now. So if a sentence contains the words knee, the knee is a part of the body, is in your leg, but just because a sentence mentions knee does not mean that it is medical. It can be something like selling socks or selling short knicker shorts or something like that, and say it's the shorts are above the knee. So instead of using just single word, you want to pair like a sequence of words. So you say maybe knee pain or joint pain or something, and you want to use a sequence of words as features versus just using single words. So that types of features are like character level features. For example, if your sentence contains like hashtags or emojis, it's easy for you to say that, okay, this is a tweet or this is coming from social media versus from a medical textbook or a dictionary or something. So that's a way that you can also start to classify. So we're just breaking down the basic building blocks for those who are already talking about keyword extraction. So the next thing you can also think about is word counts. So you can say, if in a sentence, if the word pain occurs more than 2, 3, 4 times, or at least more than twice, you know that, okay, this is likely going to be something that is health related. If the word surgery occurs 3 times or 2 times, so sometimes you not only want to have a single instance of a word, you want to look at how often words occur. I'll show you what a word cloud is, but a word cloud basically helps you visualize the frequency of words in a document. And then maybe I'll touch TF-IDF a little bit because sometimes there are some words that are very common, and if you have any rule that is based on those words, it will confuse your model. So you want to adjust for if a word is very, very common. Like if you have several documents with pain, and pain is common in every word, then in every sentence, then it becomes difficult to use that word to like classify. So you want to down rank words that are very common, so it doesn't confuse the model. I'll get to vectorization in a minute. So for your computer to start to understand natural language, there are some steps you need to do to process the input text, whether it's a question or a sentence or a tweet, some things you want to do. First of all, you want to do something called tokenization. Tokenization is a very fancy way of saying breaking a sentence into the individual words. And so once you're able to break it down into the individual words, then you can start to search if a word exists, if a word doesn't exist, how many times a word happens. So that has to happen at some point. I already talked about things like stop words. There are some words that are very common. You want to just remove them from the sentence because they are not adding much value to your interpretation or to the rules you've created. So things like and, the, there, what, sometimes is, are, you may just want to remove very common words because they're not helping you. Your rules don't even concern those words. Because you're using a computer, sometimes you have to lowercase because if you look for pain and then the pain starts with capital letter, then you don't get anything out of it because it will never find the pain with the capital letter because you only specified pain with a small letter. So you have to lowercase. Sometimes you have to do something called stemming because if you see look for the word pain and you have painful, paining, pains and all that, if you just specify your rule on pain, it will never find all these other ones because they're not the same token, but you may be able to stem or lematize. That's just remove. So stemming means you just want to retain the stem of the word, which is pain, and remove full, remove ed here, remove any other thing after it, and just retain the base form or the stem form of the word. Sometimes you might want to also remove punctuations because they may confuse your rule-based system or your model. And then of course sometimes you want to clean out unwanted characters like emojis, hashtags, and HTML tags. And then you also, these are just the basics when you are trying to teach a computer how to understand text. And so you have, because you know computers understand, are able to process text faster, then you're able to, someone asked a question about stemming. So you can, this may be a bit more technical than I want to go for the group, but basically the stem of a word and the lemma of a word may be slightly different. So the lemma will be the correct like base form of the word. And I'm trying to find a good example here. Stemming is more abrupt, is more naive, and stemming doesn't go to the dictionary to check what's the root of the word. Stemming will just remove anything at it, like full, ed, I. So stemming just has a list of suffixes that it removes, and it doesn't think about what the correct dictionary base form of this word is. But lemmatization uses like correct syntax, correct grammar to identify what is the correct base, what's the dictionary base of the word, not just using a rule-based system to remove any suffix. So that's at least the straightforward thing I can say about that here. So rushing through this because of time, and I'll switch to the document after the GitHub page and just work to that. I think I'll end there. This is, so just thinking about the process of going to computation. You then start to say, now that I've done this processing, I have these rules, I have some features, word counts, word sequence counts, and things like that, or presence or absence of a word, presence or absence of a character. I need to translate this into some form of format or language that my computer understands. And then we start to say, how do we go from words to numbers, or from words to vectors? And a very simple way to translate words into numbers is to do what I'm calling here a character index. So for every, so you know that your sentence will usually contain one of the 26 Roman alphabets, so from A to Z. So basically, if you numbered those characters in sequence, A is 1, B is 2, C is 3, and all that, up to Z, that's 26, you already have an easy way to convert any string into numbers. And once you can convert a string into numbers, then it's easier to send that down for downstream tasks. Okay, so let's actually jump through. Let's actually skip to the document itself. I don't think. All right, let's actually skip to one of the tutorials a little bit and see if we can actually work through that. Can people see my screen? Can people see my screen? Okay, awesome. Let me just check, do a quick check on. Okay, great, thanks. Trying to find where everyone else is. Okay, participants. All right, great. Okay, so let's see. This is the one I want to share. No, not this one. All right, let's do this one first. All right, so this is a notebook. There are links to the data sets. Everything is there. It's pretty easy to go through at your own time. You can download the data and just walk through the notebook. It's pretty straightforward. So this is a data set that has some information. Basically, the two columns we care about is the phrase and the prompt. So basically, you can see this is a sentence, which is natural language, and this is like the class, like what it is, what the medical condition is. So this is something. This is something that can be used to. So with this data set, you can see that there are 6,000 of them. You can use this data set to, for example, start to predict what is the disease condition. So this is a bit higher than what we were doing before, which the first project was, okay, can we separate a sentence from medical to non-medical? But now we're going into deeper and we're saying, can we actually say what is the medical condition in the sentence? So if you look at this example, it says I have a break in the skin between my thumb and my index finger, and it will not close. The class is open wound, but this sentence does not mention open wound. So your model has to figure out a way to decide that the break in skin is the same thing as wound, and you are hoping that your model will learn that just by looking at this sentence or the multiple sentences that it looks at. It's for like open wound. You can see it will learn to associate the word stitches with open wound, breaking skin with open wound, and so as you show it these examples, it learns to associate these features and it knows what to ignore. So it will definitely ignore I have a and some other things like between, but the things that you have to learn here is breaking skin and will not close. That is open wound. Those are the key words that will help it predict this class correctly. And just to go through just at the very high level, you guys are already familiar with Python, so you can just download this notebook and walk through it. Basically, it does a count of each of the classes. You can see shoulder pain is the most frequent, and the open wound is the least frequent. Like I said, there are 6,600 documents in there. Now, I mentioned a word cloud earlier, so you just want to see in the entire document what are the most common words in the data set. Like, what are the most common words that are used in the entire data set? And you can see, so the size of the text, what are those numbers to the left? Sorry, I wasn't checking the chat. Let me come back to some of these questions once I'm done. I think I'll try and wrap up in like 5 minutes and then take questions. So basically, this word cloud, and I'm just exposing you guys to concepts and just giving you a basic understanding of how to work with NLP. This is definitely not going to be an exhaustive. I mean, you can't learn how to be an NLP expert in one day. That's not possible. But this is just to help you what's your appetite and help you understand the kinds of things that can help you be successful. So word cloud basically shows you a count of different words in the data set. And you can see that in this data set, pain is very common, feel is very common, shoulder, like we said, is very common because it's the most common class here. So at least this gives you an overall visualization. But then you might also want to look at for each of the classes. So for each, so there's a disease called cough, and for all the documents that have where cough is the correct prediction or correct class, what are the most common words? And when you go through all those documents for cough, you can see they have throat, they have mucus, they have feel, they have cough, they have coughing. And so these are the kinds of things that your model would start to learn by itself to associate these words to the class. I will let you guys, I'll skip the part on part of speech tagging since I've not covered it, but that's basically if a word is a verb or a noun or an adverb, it helps your model also understand more about the word. Okay, this if this word is a verb, if pain is a verb, or let's say it's paining me, or it's causing pain. I was very pain. I'm not sure if I'm getting very good examples. You want to, your classification may be different based on the part of speech that word is in. I already mentioned bag of words models, and this is one way to, like I said, to convert your sentence into numbers. So this is a vector representing this sentence, and you can then, since your computer understands numbers a lot easier than text, you can then pass this number, this set of numbers or this vector to your model basically, to help you start to make a prediction. And then of course, machine learning, there are many ways to approach this. I don't think I will go through this at this because there's a bunch of approaches you can try. There's a lot of code here. You can go through it. But I think that the basic thing is to understand what you're trying to achieve. And then if you walk through this notebook, for example, you are able to at least build a basic machine learning model that can help you to classify this text into if it's correct or wrong. So you can see after training the model, there's an accuracy of around 92%, and but validation accuracy is 59%. So that shows that there's some overfitting there, but there's definitely a lot to pass through that I probably cannot go through in this session, but at least I think I can leave this with you, go through it. If you want to understand lemmatization, I think there's some discussion on lemmatization here versus stemming. I think this may explain a little bit of it for you. And then your classification, I mean, just a bunch of approaches. So there's several models you can use. You can use random forest, you can use naive Bayes. I mean, you can use BERT, but it is more sensible for you to start with simpler models, learn simpler models, understand how they work, get the right intuition for natural language processing before you go and use BERT for a problem that can be handled by much more simpler model architectures. So I think that's where I'll stop for today and try to take questions.
All right, thank you very much, Dr. Toby. So let's just take the questions that have not been answered in the comment section. So Uboma asked, referring to your notebook, right? A graph on your notebook. So what are those numbers to the left? I don't know if you want to quickly pick that up and then explain to her. Doctor.
I think that was it this table?
It was, yeah, I think it was a graph.
Graph? Was there a graph?
The next, I think you're scrolling to.
Was there a graph? I thought the question came in around when I was about here.
Yeah, before exactly this graph with the chart.
This one?
Yeah, no. The chart under the bar chart.
This
exactly.
One? Oh, yeah. Okay. This is the counts. This is number of times this class, this target class, this prediction or this condition occurred in the. So like I said, you have 6,000 sentences, and so this is basically counting how many times these classes occur. So it's just a count. So this one occurs 35 times. This one occurs about 34, 33, 32, or something like that.
Okay, so she said it's actually the numbers, the 4-digit number, exactly this one.
This one. Okay. Yeah, okay. Interesting. So this is just the index. So this is they're using pandas. So when pandas prints out is the row number. So this is just the row number. So you can see that it is 6,661. So the sentences will go from number 1 to 661. It just so happens that when they sample this random selection, these are the row numbers. So they don't mean it's just the row order. So because it's randomly sampled, it just grabs any row. So these are the 10 rows that were selected.
Right. Guma, I hope that explains your question. Okay, the next one, Kilamo asked, what's the maximum length of words that the model can work with? Yeah,
that's a very good question. So there are models with different architectures and different capacities. There are some models that can take a large amount of text, some can take very small. So usually, your problem, your research problem defines like what kind of model architecture you pick. And so you want to pick the right model for your problem. If you are processing large documents like in healthcare, then you would either be looking at models like Longformer or that process long text, or you want to use an architecture like an LSTM that can process a lot more text than, for example, CNN. If you are using something like TF-IDF with naive base, then you don't really have that same constraint of like sentence length, because they have a fixed length, which is your dictionary size. So, and that will be limited by your machine, at the RAM on your machine, and things like that. So there's multiple things to consider when trying to pick a problem to solve. I think what some people have done is, if you have a model that you are sure is good, but it doesn't have as much capacity in terms of size, then there are problems where it makes sense to split your sentence into chunks, or your passage into chunks. So it can process the first chunk and process the next chunk. That's another way if people have solved this problem.
All right, thank you, Doctor. We have some of our participants who joined us from YouTube. So there's a question from there, which is that, haven't built a model like this, how can we implement it in real life?
That's a good question. I'm sure you guys have a class for deployment, but basically the approach is to think about the point of service. Where is the model needed? What kind of device is it going to be used on? Is it a mobile phone? Is it a laptop? Is it a desktop? Is it on an IoT device, or some fixed machine like an MRI machine, or an ultrasound machine, whatever? So that's what determines how you think about deployment. If you does the point of contact, or the point of service, does it have internet access? Does it not have internet access? If it has internet access, how reliable is internet access? So if it's reliable and all that, then you can deploy this like remotely on a server with whatever GCP, AWS, or Azure or something. But if there's no internet, or it's not reliable, then you might want to think about a local deployment. And please feel free to reach out to me if you guys have specific use cases where you are trying to deploy something, or thinking about a specific problem. Please reach out to me on LinkedIn, and I can see if I can help.
All right. So before I take this question, like Dr. Toby has said, his LinkedIn ID has been dropped. To also be dropped again for those of us that not pick it. You can reach out to him, right? He's willing to answer any other questions you might have. So just one more question from Moses Daudu. Our time is fast spent, but I believe we can take this. Moses said, are neural networks better for NLP or conventional ML models?
Yeah, very good questions. And if you're ever doing an interview for a machine learning position, this is kind of question they may ask you. And just as a warning, anybody whose default answer to every question is BERT or large models, that person has failed automatically, because you need to be able to match a problem to a solution. So you need to know the options you have for ML models. And a principle in computer science called Occam's razor. And it says you should always prefer this simpler solution. So if there's a problem that can be solved by a logistic regression model that can run in less than 1 second, why should you then go and take a heavy chat GPT that will run in 10 seconds to try and solve the same problem? You're consuming more resources and wasting people's time. So you want to match. So the way most people want to approach it is to say that you've tried a simple method, and you have proven that the simple method, like a naive Bayes or a random forest or a boosting or some other treasure method, cannot solve that problem. Then you go, okay, I want to go to an LSTM, an RNN, a GRU on LSTM. If that does not solve it, then you can say, okay, then we can use a large transformer model or something. So that's the general guideline for like best practice.
Right. Thank you, Doctor. Moses, I hope that answers your question. The questions are lots, right? And I know that I mean, we really want to take them, but I will Doctor, just one more, right? I know our time is fast spent. Just one more question, and then guys, you can please, right? I would have loved to take all the questions, but our time is fast spent. Why not? You can reach out to Dr. Toby, right, on LinkedIn. Doctor, they mentioned that your DM is not open, so I don't know if you can help open it so that they can reach out, if that will be fine, Doctor.
Yeah, I think just send a connection request or something. Okay. That's the first step, and then once you do that, I should be able to. I'll see it and then accept or something. I think that's how. I don't think LinkedIn allows anybody to just open up their DMs to anybody. Let me try and address one or two of the questions on how to use the notebook. So,
please go ahead.
Yeah. For the notebook, everything can run in the notebook. The models can be imported and run in the notebook. So everything, you don't need any additional software. All you need to do is pull the notebook. You need to, of course, import or install the required packages. I think for this one, the list of packages you need are already there. So if you know how to install anything in a notebook, that should be fairly straightforward. How to import, for example, yeah. So here, these are two models that you can use. That just by importing it, you already have the model, and then you can train it. So this is to use split your data into train and test, and then you easily just train. Where is training? This is the pipeline. You count the words. You remove the ones that are very frequent, or you adjust for the ones that are very frequent, and then you train. And so this is just one line to train this model on your training set, and then you test it on your test set basically, and look at the score. The accuracy on the test set is 9%, which means there's still some work to do to improve. And then you can do some in this second notebook. You will see that, which is a lot more detailed. You will see that the first time they trained the model, the score was not very good. So this is the first time they trained this model, and it wasn't very good. There were many mistakes, very many mistakes. You can see this score was 25%, so that's not very good. And then they went and then they did some work on it, improved the features, added more features, condensed the classes. Then they trained a different model again on it, and now they improved that score to 59%. Then went back again, added some features, did some balancing of some minority classes, and then used the logistic regression this time or something, and then they are able to get a better score. They are now at about 62%, and just keep going and iterating and improving the quality of your model. So it's not just a one-line thing, basically.
Right. Thank you, Doctor, for that clarification. And I think that was quite insightful for our participants, right, to help them. Paulina, we need to go now. But Doctor, just Paulina's last question, and this is going to be the last question. So he mentioned, he said he usually strips out, it's not NLP related, so it can be beneficial to a better person. It's not health related, so it can be beneficial to every other person on the call. So I usually strip out emojis when cleaning my text data and preparation for the vectorization step. I don't convert them to corresponding words. I feel it gives undue advantage to texts that have emojis and so change those that don't have to avoid bias. Doctor, do you think I have been right with my approach?
Yeah, so again, I said, so your decisions will be based on the problem you are trying to solve. So for example, if you are training a model, for example, when you're doing sentiment analysis on tweets, you want to know if this tweet is positive or negative, is happy or sad or something. That is a situation where you want to retain all your emojis, or at least most of your emojis, because Your emojis already have those, there's a smiley emoji, there's a sad emoji. So it doesn't make sense if you are doing that to remove your to remove the characters or emojis. That's a situation where your emojis are going to help you make a more correct prediction, because you're going to make the work significantly harder for yourself if you remove those characters. So that is one situation where you want to definitely keep them in. So you don't, there's usually no one size fits all rule. You basically have to think about your specific problem and what the best solution might be. All right.
Okay. Any doctor?
Yep.
Thank you very much, Doctor, for that. I think, okay, guys, thank you very much. I think we can just drop our emojis to let Dr. know we super appreciate the session and all the time he has taken to answer all of those questions. Dr. Toby, thank you very much for the detailed and explicit introduction to NLP for healthcare solutions. All right, thank you, guys. Thank you. Let's keep coming while I just pull up my screen, and then we will round up the session within the next 2 minutes. Okay. Dr. Toby, thank you very much. And we will, of course, the students will reach out on LinkedIn and get a lot more insight from your wealth of experience. So guys, just to let you know that this is the first masterclass, right? We are also going to be having the next second masterclass. But before I go to that, we have this upcoming event that we will be having across these cities, right? In Senegal, in Kenya, and in Nigeria, where we'll be talking a whole lot more on just spatial and mobility data for health, mobility data for health workshop. So it's holding in 3 different locations. As a member of our community, right, please stay open to receiving more details about this, and also on all of our social media platforms, details about this will be shared, right, so that you can find a way to be a part of them, of these sessions as convenient for you. The next class will be the second masterclass in this series, right, where we'll now be looking at the automatic speech recognition, right, and its application. We'll be having Abraham Oduni next week, right, Thursday next week, same time, and he will come and then he will do a deep dive into automatic speech recognition and its applications in healthcare delivery. You do not want to miss that session, so I would ask that you please register and be a part of that session. It will be a sequel to what Dr. Toby has shared in today's session, so ensure you're a part of that session. So once again, thank you everyone for an amazing time today. Thank you for being a part of this session. We sincerely appreciate. At the beginning of the session, I appreciated every one of us for being a part, because you are the reason why we are here on this call. Thank you for staying all the way to the very end. I want to believe that you have gained one of 2 things that you can really begin to research more about and see how to implement. And of course, the connection to Dr. Toby, right? Some of us can reach out to him on LinkedIn and then also glean from his wealth of experience in implementing NLP to solve healthcare problems. Once again, thank you for being a part of this session, and we look forward to seeing you same time next week on Thursday as we continue in this masterclass series. I want to believe that it has been an amazing session for you, and we are glad that you're a part of it. Do have a great evening, everyone, and bye for now.